Today we're going to be studying mathematics.
And emerges from the second mirror.
These words sound
Be your teacher for today. Hello class, you are welcome to MSI Tech Online Home Lesson. This is another topic for today. I'm very happy and so excited to see you in the class today. Today we are considering another topic, indices and standard form. So under this, I'm going to give you about 6 basic laws we use in indices, and I'm going to explain standard form, how you can bring down long numbers into a standard form. So let's start with laws of indices. Okay, laws of indices. Now the first law is talking about a raised to power x times a raised to power y. This will give us a is common to both, x plus y. Okay, now don't get confused with this. Let me give you an example where to apply this formula, okay, or where to apply this law. Let's say for instance, example is given to you. Evaluate 10 raised to power 6 times 10 raised to power 3. Okay, now seeing this, it might look so big if you are writing 10 times 10 times 10 in 6 places, 10 times 10 in 3 places. So instead of that, you can apply the law of indices, which we have 10 raised to power 6 times 10 raised to power 3 equals to 10 is common. You are going to have 10, 6 plus 3. Okay, just like what we did here, this will give you 10 raised to power 9. So you can still have another example where you can apply this formula. I will explain that to you as we continue in this class. Now let's look at the second law. The second law can also be called division law. Let's say for instance you have a raised to power x divided by a raised to power y. What are we going to have? We are going to have a is common, x minus y. Okay, now let me give you an example where we can apply this formula. Okay, example 2. If you have something like 6 y raised to power 4 divided by 2 y raised to power 2. Okay, how are we going to apply the formula here? Now we have 6 y raised to power 4 divided by 2 y raised to power 2. This will give us 6 y raised to power 4 divided by 2 y raised to power 2. Okay, it's the same thing. 2 here 1, 2 here 3. We have 3 y raised to power 4 all over y raised to power 2. Y is common to both. Okay, apply this law. We are going to have 3y, that is 4 minus 2. This will give us 3y raised to power 2. I believe you understand this. You know how to apply this. Okay, now let's go to the next law. We can call it third law. Now this third law is trying to explain, sometimes we call it negative law. Okay, we call it negative law. Let's say for instance you have y raised to power minus n is going to give us 1 y raised to power n. Okay, just like you have y raised to power minus 2, which will give us 1 y squared. Okay, now let me give you an example where and how we can apply this law in any equation. So this one will give us example, evaluate y raised to power minus 5 divided by y raised to power minus 10. Okay, I believe you have seen something like this before. Now let's apply this law. We are going to combine this law and also we combine this law. Let's see how we can integrate this law together. This will give us 1 raised to power minus 5 divided by 1 raised to power minus 10. This will give us 1 over 1 raised to power 5 divided by 1 over 1 raised to power 10. Remember, we are applying this law. Okay, now what we are going to do now, there's what we call law of reciprocal. And this law of reciprocal states that if you have something like this, we have y raised to power 5, this will turn to times, and your denominator will go up, numerator will come down. Y raised to power 10 over 1. So if you multiply numerator, we have y raised to power 10 all over y raised to power 5. Okay, now we are not going to leave our answer like this. We are going to apply the second law. And when we apply the second law, just like what we did here, y is common. You pick y, 10 minus 5. So our answer will be y raised to power 5. Okay, so this is how we can apply the law. We have different questions, but the basic things you need to understand is the law, each laws, then you know where to apply each of these laws. Now let me go to the fourth one. Okay, let me go to the fourth one. Okay, the fourth law, sometimes we have something like n raised to power 0. Okay, this is talking about zero law. N raised to power 0 equals to 1. X raised to power 0 equals to 1. So this is telling you that any number or any letters you have the power of 0, it will be equals to 1. Let me give you an example. Okay, how to apply this. Let's say simplify 2x raised to power 5 multiply by multiply by 4x raised to power 2 times y raised to power 0. Okay, now let's see how to apply this law here. This one will simply give us 2x raised to power 5 times 4x raised to power 2 times y raised to power 0 equals to this. We are going to have 2 times 4 will give us 8. This will give us 8x. You apply the first law. We are going to plus this, okay, times 1, because y raised to power 0 equals to 1. So this will give us 8 x raised to power 7 times 1. So 8 times 1 will still give us 8 x raised to power 7. I believe you understand where to apply this law. So let's go to the fifth law. What do we have in fifth law? Let's see it. The fifth law is talking about a 1 raised to power n. This will give us the square root of n of a. Okay, so this will give us a n. Now you can also have something like x 1 raised to power n. It will also give us the n will come out and the x will come in. Okay, let's say for instance you have something like 5 1 over 2. Okay, applying this formula or law, you are going to have, since n is the one outside, that means half will be outside, 2 will be outside, okay, and x will be what? Will be inside, which is 5. Okay, Now let's see where we can apply this formula in the real example. Let's take a look at this example. Okay. Okay, now let's solve these questions together. We have 125 raised to power 2 all over 3. So what are we going to have here? 125 raised to power 2 all over 3. So here we are going to have if you look at this, applying this, we are going to have 125 squared. Okay, now you need to look at this. This can still, we can still break it down. 3, let's look at 125. 3. Okay, 5. How many 5 can we get in 12? 5 in 12 will give us 2. Okay, remainder 2. That to put it here, we have 15, right? I mean, we have 25. 5 in 25 will give us 5. So we are going to have 5. 5 here. 5 in 25, 5. 5 in 5, 1. So we are going to have 5 raised to power 3 squared. Okay, this one will now give us 3 5 raised to power 3 squared. Okay, this will give us, this will cancel this, we have 5 squared. Okay, 5 squared will give us 5 times 5, which will give us 25. Okay, now if you go through this, you understand that we applied the formula here. So all what you need to do is understand these formulas and you can solve any question. So I've explained the laws of indices, but let me just give you one example, general example, how we can apply these questions using the laws of indices. Okay, let's look at this question. We have simplified 1 all over 81, and you can see this. Let's solve this. 1 all over 81 raised to power minus 1 over 4. Now, looking at this, applying the last law, we are going to have 3 raised to power 4. Okay, minus 1 over 4. Okay, now let me explain to you how we get this 3 raised to power 4. If you have 81, okay, you have 3. How many 3 can we get in 8? 3 times 2, 2, right? 6. Remainder 2. Okay, how many 3 can we get in 21? That is 7. Okay, how many 3 can we get in 27? 3. 3 in 3, 1. Okay, this will give us 9. 3 in 9 will give us 3. So this will give us 3 times 3 times 3 times 3, which will give us 3 raised to power 4. Okay, 1, 2, 3, 4. So that's how we get this 3 raised to power 4. Now, if you apply the law of reciprocal, something will happen here. And what is that? You are going to have 3 raised to power 4 over 1. Then 1 raised to power 4. Okay, this 4 will cancel this 4. You are left with 3. So if you apply these laws of indices, you can solve any question. Now let's go to the next part. The next part is talking about indices applying exponential and index. So you might find some question like the example that I'm about to give you now. How can you solve such question? So let me give you an example. Okay, now let's look at this simple indicial equation. Simple indicial equation is referring to equation where we have exponential, and this is referring to this, and sometimes we call it index. Okay, now let's look at this together. We have 4 raised to the power minus 3x equals to 1 over 64. Okay, now if you apply this, what are we going to get? Okay, this will give us 4 raised to the power minus 3x 1 over 4 raised to the power 3. So 4 raised to the power 3 is the same thing as 64. So what are we going to do? We can apply the negative law. That is why you need to understand each law. So we have 4 raised to the power minus 3x. This one will give us 4 raised to the power minus 3. Okay, now you can see that 4 is here, 4 is here. We have minus 3x equals to minus 3. Divide both sides by minus 3, divide both sides by minus 3. This cancel this. X will give us minus times minus 3 divided by 3 will give us 1. So this is what we call simple indicial equation, and we can call it exponential equation. I believe you understand it. So let's go to the last part, which is standard form. I know that you know this before, but I just want to refresh your brain in case you might have forgot some of these things. So let me give you a brief explanation of standard form. Okay, now this is standard form. How do we get standard form? Let's say, for instance, let me give you this example. Express the following in standard form. Okay, we have 0.382, we have 6.251, and we have 3.25. Okay, let's quickly look at this. How can we express this following in standard form? Let's start from number 1. We have 0.382. Okay, now what are you going to do here is this. You are going to convert this. This is decimal. You convert it to fraction. So how are we going to do that? Pick 1, 0, 0, 0. Pick this value. We are going to have 382 divided by 1000. Okay, now this 1000 can be written in a standard form. Okay, this will give us 382 divided by 10 raised to the power 1, 2, 3. 10 raised to the power 3. Okay, now the law of indices will have to come in here. So when you apply law of indices, we have 382 times 10 raised to the power minus 3. But you are not going to leave your answer like this, because we can still convert 382. So when we convert 382, we are going to have 3.82 times 10 raised to the power 2, then times 10 raised to the power minus 3. It's just like you have 382. Okay, 382 will give us 100. That is 3. You put your point here, 82, then you multiply by 100, which will give us 3.82 times 10 raised to the power 2. So this is what we just explained here. Now apply the first law of logarithm here. This will give us 3.82 times 10 raised to the power 2. You know, you are plusing it, plus minus 3. Okay, now this will give us 3.82 times 10 raised to the power 2 plus minus 3 is going to give us minus 1. So this will be our answer. Okay, I believe you understand that. Now let me go to the second one, which is B. We have 6.251. This will give us 1 0 0 0. Okay, pick the number 6251 all over 1 0 0 0. This will give us 6.251 all over 10 raised to the power 3. So this will give us this will give us 6251 times 10 raised to the power minus 3. Okay, now you can still convert this 6251. You are not going to leave it like this. We can still break it into standard form, which will give us 6.251 times, you put 1 here, is 0 0 0, that is 30. Yes, times 10 raised to the power minus 3. So this will give us 6.251 times 10 raised to the power 3 times 10 raised to the power minus 3. So you apply the first law of indices here. You are going to have 6.251 times 10 raised to the power 3 plus minus 3. This will give us 6.25 times 10 raised to the power 3 minus 3 is 0. So you can leave your answer like this, and if you want to write it, it can also be 6.25 times 1, okay, which will give you 6.25. So this is what we call a law standard form. You can apply this to any question given to you. The most important thing you need to know is know all the laws that guides each of these questions. Okay, I want to leave this C for you. I trust you can do it, right? Okay, so before we leave this class, I want to give you something to do for me till we meet next class. Okay, so let me add something to this, but you are still going to solve this C for me. Okay, you are going to solve that, but I still want to give you something. Okay. Okay, class, this is homework for you. Number 1, evaluate 9 raised to the power minus 2x equals to 1 all over 27. Number 2, simplify 24y raised to the power 4 divided by 2y raised to the power 2. Then number 3, express the following in standard form. We have A is 0.7625, B 654,000, C 6.251. You can also add this, the C part that I saw for you, that remain, you can add it to your own work. Thank you very much. So excited, I'm so happy to see you in this class. Until we meet next time, thank you very much. Remember, if you have any question, you can always send your message to us via WhatsApp number rolling on the screen, and we promise you that we are going to get back to you. Thank you very much. See you next class. Au revoir.